Okay, hello. This is my first teardown video, and what we have is a circuit breaker. It's a standard Hager 6 amp B curve circuit breaker that was used for a domestic lighting circuit here in the UK, and it tripped out on a short circuit and now will not reset, which I think means that there's a mechanical linkage inside that's broken. Probably because they're designed down to a cost, but they are also designed to fail safe rather than fail in the closed position, which would be extremely dangerous. Now, I have hopefully prepared all the tools I will need. Now, these breakers are DIN rail mounting, and there's the mounting bracket there to connect to the DIN rail. Now, I should be able to remove this mounting bracket by bending it. Should, I believe, just lift off like this. This could be hilarious if it goes wrong. No, it's not going to come off like that. I'm just trying to figure out how it's... Seeing as I'm disassembling this and it's a teardown, it doesn't really matter if I damage it, does it? So I will bend it like that. This is just a metal clip. The very cheap breakers have a plastic clip that attaches it to the DIN rail. I have a container here for all the pieces. Now that's removed that piece. Now the only bit remaining, the only thing holding it together now are the 4 rivets, which you can see there, there, there and there. And I have prepared a drill, so hopefully I should be able to drill these out. Now what I'm having to do, you can probably see, is go in at a slight angle because the rivets are not tight and they try to rotate along with the drill. And this is made of a thermoplastic material rather than a thermoset, which you would think of for circuit breaker casings. But still, I guess it's cheaper. Now, just to clear up the mess here, I'll just sweep this mess into the rubbish container that I've prepared. Now, I should be able to grip them with these nippers here. Yes, the rivets are just pulling out, which is what I was hoping for. I might have to fiddle with a couple of them. There we go, and the last one seems to be loose. There we go. Now, if you look carefully at this, you see there's a line here. So this is a separate piece, which should, in theory, just lift off. Famous last words. What I'm trying to do is leave all the internal workings in place. Now, for some reason, it's being difficult. Ah, there we go. Oh, look. Doesn't look very healthy, does it? That's all vaporized copper from the arcing that's been going on when it trips. This did, as I said, this did trip on a short circuit. It's only a 6 amp breaker. The short circuit was in fact a blown GU10 light bulb. I see why it was being difficult. The little plastic cover I've thrown on the floor, which I will pick up. This little plastic cover which I threw on the floor, I don't know whether the autofocus will handle this. No, it won't. I think once it's focused and started the video it won't stop. But this is just the rating plate, which I should apparently have unclipped first. As you can see, there's nothing here except for this piece, which is a... no, that's a nylon piece that just protects the side of the moulding from the flash when it breaks, because these have a, doesn't say, I think these are 10,000 amp breaking capacity. Now what you see inside, I'm not going to try and show you try and find out what's wrong with it on camera. Oh, I see, I think. Well, it's not going to work now because I've just removed part of the linkage, but I think part of the metal linkage had gone in some way. But anyway, these, let me just try to reassemble this slightly so you can see how it would have been in use. I should have done this before I disassembled it, but oh well. I'm just gotta, there we go. There, it's even closing and opening again. Right, what you can see here, the pieces of the circuit breaker are, now this is the top of the breaker here, and this is the bottom when it was installed. So this here would be the input terminal from the live bus bar. Now what you see here, these very, very heavy duty terminals with a rising clamp arrangement. I don't know whether you can see that. As you tighten it up, the little metal clamp rises, gripping the cable without being directly under a screw terminal. They're a much better way of achieving a connection, and this is designed for the bus bar, which was the permanently live section. Now this section here, it goes from there through a flexible cable into this piece here, which I don't know whether it shows, sorry I'm not showing it very well on camera. This piece here has a coil of wire around it, which I believe is only, no, that is the whole, yeah, that is the whole piece of, that's the whole current of the circuit breaker is travelling through that. And that is a bimetallic strip like you find in a thermostat. And that is what trips on overload, and you can see there's a tiny grub screw there, which is the manufacturer's adjustment, and there was a small hole in the base there that the manufacturer can adjust with a tiny Torx screw to meet the correct current curve. Now once it's passed through the bimetallic element, which has a mechanism here which moves when the bimetallic strip bends, it moves this mechanism which would have released this catch here, which is broken, which is why it wouldn't reset. Aha, we get to the bottom of the story now. Normally this would have been clamped like that against the spring pressure, which is in this mechanism here, which I'm not going to take apart on camera because it will probably flick out and hit me in the eye. But this would have been closed against spring pressure on this contact here. When this contact opened, you can see what happens is the current goes, sorry I'm not doing this very well, the current goes from here through it comes in from the bus bar, through the thermal element, through the moving contact assembly, to the fixed contact assembly, and then goes through a coil of copper wire here, which is magnet wire or enamelled copper wire, which is basically a tiny electromagnet. And then from there goes to this terminal here. Now what you will find there's some very clever engineering gone in here. The current is arranged to travel through here. The current actually travels through this section here, and these pieces here are nothing to do with the electrical path at all, although they are, I believe, copper or brass. That is the arc quenching mechanism, I suppose you'd call it, although there's no moving parts. The arc, as the circuit breaker opens, the arc will tend to expand in this gap here, and the magnetic force will connect it. Oh, I see, yes. It will try to connect it. Oh, very clever. Sorry, I'm learning myself here. I believe that the arc would have passed on to here, maybe. No? No, maybe I'm being a bit clever. I suspect somebody on YouTube will be able to explain to me exactly how this works. I can probably even look it up on Wikipedia myself. But this here absorbs the energy of the arc, cooling it down and making sure that the ionised air is deionised by the time the next peak of the main cycle comes along, so it doesn't restrike. But then it goes from that magnet. That's the instantaneous trip, by the way. This has been a horrible video, hasn't it? This is the instantaneous trip. That plunger pops out when the current is massively the current rating's massively exceeded, as in on a short circuit or incredibly large overload. That will pop out and trip the breaker instantly. Whereas this one, as it bends slowly, this absorbs small inrush currents without bending enough to trip. So you can run motors and things like that without it tripping. And then it comes straight through to this terminal here, which is the connection for the wire. So let's actually do the teardown now. You can see how these rising clamp terminals work. If I show you from the back, you see the wire goes in this hole here, and as you tighten the screw, this clamp piece moves up. The screw actually remains locked in position, and the clamp itself moves up, meaning that the wire doesn't move that you're connecting to, and the wire is not borne on directly by the screw. This is just the trip-free linkage, this is called, meaning that it can, even if the breaker is mechanically held on by somebody physically holding it on with their thumb or for any other reason, it can still trip. Now this, as I said, was the trip mechanism itself, which is probably part of the problem. I suspect, yes, there's a lot of wear in there. This breaker had apparently tripped several times, because it trips every time the GU10 halogen light bulbs trip. So I suspect I'll be changing the breaker again and again and again. Yes, you can see there's a broken piece. Well, I can see there's a broken piece in there that shouldn't be there, and the arcing has actually melted away this end. I don't know whether you can see that end has been melted by the arc, which is why it wouldn't reset. Okay, that's one mystery solved. Now, as you see, I cut this free. Now this clamp terminal here should cut free. This is just a different version of the rising clamp terminal that was used at the other end. What I'm trying to do is get at the... there we are. That's the actual bimetallic strip. There's the heating element which carries the current through, and it was welded onto there, spot welded at one end. There we go. I'm just removing all of this, remove the insulating sleeve. All that was to do was to prevent the element, the heating element being short-circuited, which would render the thermal part of the circuit breaker ineffective if that happened, which would not be a good thing. But what I'm trying to do here, quickly, because I'm running out of time on this video a little bit, well, I've gone over what time I was expecting to take, but you can see that's currently quite straight, this strip here. Let's see if it will physically bend. Not so much. It is bending. I don't know whether you can see that. It's no longer the perfect straight line it was. It's got a curve in it. It's not anywhere near as spectacular as a thermostat is. If I had a lighter that wasn't out of fuel, it would help. I do in fact have a propane torch. We'll try that, see if we can get a slightly better effect with that. I don't know whether we will. This is obviously far more heat than it would ever have in normal use, but you can see the effect. It's bent that into quite a curve there. There, you just see the curve now. And if I let it cool down, you'll see it eventually come straight. And that is how they work. They just literally, as it heats up, it bends and pulls on the trip mechanism, which then trips the breaker. This is the return spring for the handle of the breaker. That's all that did, was return the handle. This is the arc chute that you've already seen. It's a bunch of pieces of copper or brass strip, not connected together, but they absorb the heat and cool the arc down to the point where it's no longer ionised. This is the magnetic part of the circuit breaker. It's got a return spring in there. If you pass a current of over 6 amps through there, it will probably pop out, I would imagine. Shall we try that? Let us see. I have conveniently here a battery, which is charged to approximately 6 volts DC. This could go spectacularly and horribly wrong, but let us just try. That's what YouTube's all about, isn't it? Trying to see if things are going to go spectacularly and horribly wrong on camera. I'm just trying to basically get this locked into contact with this terminal. There we go. This battery was actually from a scrap piece of equipment, so... Whoa, that was very, very spectacular. But did you see... I don't know whether you can see... Did you hear the clicking there? Let me try this with a longer screwdriver. I'm quite worried about getting showered with bits of molten copper here. Let's see. This should be quite an interesting... No, I don't think you can see it. It's not quite... No, there's not enough current there. This is probably... Although it sounded like it was moving, I don't think it actually was, or not far enough. I mean, that would have been more than enough to trip the breaker, but the movement is so tiny, and I was flinching every time it sparked. Because I really wasn't expecting it to be quite that vicious. Because this battery was rescued from a dead item. I really wasn't expecting there to be any charge in it at all. But there was, so we can't say I didn't try. And No, it's not even warm. And that's the magnetic part again. This is the trip linkage that linked the magnetic, thermal and trip magnetic part, thermal part and trip mechanism. I don't know whether I can get that out or whether it matters. There we go. That's the other shield. And we're now down to the bare base of the breaker. And that, as they say, is that.